Hi, my name is Sophia Robles, and in this video, I'm going to demo how I implemented the Sales Star schema assignment using PDI. So you'll see how I built the product dimension with STD type 2 and then enhanced the sales fact table, and I will also show just validating all of the data integrity of that. Okay, so I'm going to start at the just showing you an overview of the completed star schema that I created using the reverse engineering feature in MySQL Workbench. Um, so you can see here the star schema. Fact sales is at the center. And then it points to these three-dimensional tables, dim date, dim customer, and then dim product. And you can see that all of the foreign key relationships have been fully or properly established, because when you hover over this, it's highlighted the relationship there on all three tables. And then in that each dimension uses surrogate keys. So for dim date, that is date's key. Dim customer, it's customer key, and then product, it's the product key. Okay, so now just looking at the populated tables to verify that everything was loaded correctly. I'm just gonna run this first query on the dim product table that was created. So you can see here it contains all 11 products from the product CSV file, and you can notice that the SCD type 2 fields, product key is our surrogate key, and then we have version, date from, and date to here at the end, just to track any like historical changes. And then at the top is the dummy row with the product key equal to -1. So this is just for when a product lookup fails. And then to look at this fact sales table, I'm gonna run this query. So you can see here it successfully loaded all of these transactions, and so each row has surrogate keys linking to all three dimensions, that being date key, customer key, and product key. And then just other measures such as like quantity, unit price, discount, tax amount, shipping cost, and then the calculated extended sales amount. So with that, you can notice that some of these records also use the -1 keys. So these are cases where the dimension lookups failed and the dummy rows or the dummy row processing handled them correctly. Okay, so with that, I'm just going to walk you through now my implementation approach. So looking at the key changes I made in order to complete the assignment. So starting here in the build dim product KJB, for the first task, I needed to build the product dimension with SCD type 2. So the job has three main steps, that being create dim product, which is the SQL step to create the table structure, and then coming here to the second one being load dim product. This is just loading, this transformation just loads the actual data. And then finally here you can see set dummy rows, so sets up the -1 dummy row. So just clicking here to show you the SQL. So there's the create table statement. So I included product key as surrogate key with auto increment, and then all of the business columns from product CSV. Those, I'm not going to list them all, but you can see all of the columns there. And then SCD type 2 fields being like version, date from, date to, and so forth. So just mirroring the customer dimension, but with product specific fields. Okay, so now I'm in the load dim product transformation. So this loads, as its name says, the product data. So you can see here we start with the product CSV to interpret the source data or read it, and then we sort the rows by product ID. This is just a requirement before the dimensional lookup. And then this final part, dim customer, or this handles the SCD type 2 logic. So I'm gonna, or this is dim product. And then, so you can see here, I'll click into this. So the keys tab shows that records are looked up by using product ID as the business key. So just matching products between loads. And then the second, like, field and stream or technical key being product key. So this is just the surrogate key that gets auto-generated. So I'll click here into the fields tab. So this lists all of the attributes we're tracking for changes. So you can see all of these. And so when any of these changed, a new version is created with the updated date from and date to values, which you can see down here at the bottom. And so that is just how the SCD type 2 tracks history. So for task 2, I needed to enhance the sales fact table to include the product dimension. So right now I'm in the build fact sale file. So you can see here the job has a few steps, but the key one that we're looking at is the surrogate key pipeline. So I'm going to click into this. So I modified this SQL just to include the product dimension. So right here in the select clause, you can see that I added the product key to bring in the product surrogate key, and then I added the left outer join and I did this instead of an inner join. So if the product ID doesn't exist in dim product, it would still keep the sales record. So in that case, the product key would then be null. And then you can also just note the date conditions for SCD type 2, where it's matching the product version that was valid on the sale date. And then I also added the update statements just for dummy row processing. This replaces any null product key values with -1, which points to the dummy unknown product row. And that prevents just like referential integrity errors, and then preserves all of the sales data. And so with that, finally, it takes us into the create foreign keys step. So that adds the foreign key constraint from fact sales to dim product, and then establishes that relationship within the actual database. Okay, so now just to demonstrate running the complete ETL process from start to finish, I'm here in the main build dims all, or dims in fact, KJB file, and I'm just gonna click run here. So this file orchestrates everything. It build dim all builds all 3 dimensions, being date, customer, and product, and then the build fact sales creates and loads the fact table with surrogate keys. So you can see here it just ran successfully without visible errors. So you can see that all dimensions were built, product dimension loaded all products, and then fact table processed 34 sales records, and then with that, that means that everything executed cleanly, just without failure. Okay, so now I'm back in MySQL after running that in PDI. So here we're going to validate the data integrity by comparing source data with the fact table. So I'm going to run this first query just to validate row count. So you can see that the source table has 34 rows with 54 total units, and the same for the fact table. So that's a perfect match. Which confirms that we didn't lose anything during the ETL process. So now doing the same or similar to verify the sales amounts. So you can see that the source table shows base sales total, that being $9,664.46. And then the fact table extended sales amount is higher, as that's $10,173.30. So that confirms that this ran correctly because extended sales amount includes taxes and shipping costs, not just the product price. So calculation all working as designed. So now I'm going to come here to the next query, just to confirm that verify the dummy row processing. So I'm going to run this. So you can see that we have 34 total rows, 0 missing dates, 2 missing customers. These sales had customer IDs that weren't in dim customer, so correctly use the -1 dummy row. And then you can see at the end, missing products is 1. This sale specifically had a product ID that wasn't in dim product, so it correctly used the dummy row there as well. So that proves that the left outer join and dummy row processing is working perfectly. And instead of losing the 3 problematic records, we preserve them using the dummy row keys, or -1 keys. So that's just maintaining data integrity while flagging records that needed investigation. So that concludes my demonstration of how I implemented the sales star schema. Thank you for watching.